This is an IGCSE Edexcel Physics Paper 2 talk-through from June 22. There's our all-important equation sheet. A student uses a watt meter to measure the power of an electrically operated appliance. State what is meant by the term power. This is the rate of energy transfer. The student measures mean power output in watts for 6 different appliances. Here are the results. Draw a results table for the student's results. So we want to have the appliance as one of the column headings, then the power together with that all-important unit, and then just complete the table. So we have a toaster. Whatever you do, don't write the units in the main body of the table. Kettle. Laptop. Electric drill. Television. And hairdryer. Gosh, that uses a lot of power. The student measures the power output for a different appliance. Diagram 2 shows their raw data. The student identifies an anomalous result, i.e. the odd one out. Draw a circle around this. So they're all around 200, which means that this one here is the outlier at 213 watts. Calculate the mean power output for this appliance, give your answer to 3 sig fig. So to find the average or mean, we add up all the values which aren't anomalous. And then divide by how many there are. 1, 2, 3, 4, 5. And then they want the answer to 3 significant figures. This question is about momentum. Which of these is the correct unit for momentum? So momentum is mass times velocity. The unit of mass is kg. The unit of velocity is meters per second. So there is your unit for momentum. Don't allow yourself to be confused by the first 3, which aren't the same. It's D. The diagram shows an object before and after an explosion. The object breaks into 2 parts, P and Q. They move apart from each other in opposite direction. State what is meant by the principle of conservation of momentum. It's that momentum before equals momentum after the explosion or collision or whatever it is. Calculate the magnitude of the velocity of part P after the explosion. So let's write that again. Momentum before equals momentum after. So what is the momentum before? Well, it's its mass times its velocity. We've been told it's stationary, which means it has no velocity. Then the momentum of P is its mass 2.9 times that speed, that velocity that we're after, added to the momentum of Q. Just be careful, P and Q are moving in opposite directions, so I'm going to put a minus to show that. And then just work out the left and right side. By definition, that's 0. This becomes 2.9x minus 7.03. Add 7.03 to both sides to get 2.9x on its own, and then divide by 2.9. So here's your final answer. A child drops an egg from a height of 10 centimetres and the egg lands on the floor. Explain why the egg is less likely to break if the floor is covered with a thick carpet than if the floor were covered in hard tiles. This is one of those momentum questions. It's like the crumple zone or airbag one. What's going to happen if you have that thick carpet is that you increase the impact time. So according to this equation, force equals change in momentum over time. Using a thick carpet will increase the time of impact. For the same change in momentum, meaning that a reduced force is felt by the egg, hence why it doesn't break, or less likely to break. Mobile phone charger X contains a transformer and is used to charge the phone's battery. We've got input, output voltages, output current. The power can be calculated using this. Calculate the output power of charger X. So power equals current times voltage. So it's 1.2 times 5, which is 6. Calculate the input current to charger X. Assume that the charger X is 100% efficient. This means you need to use this equation. So what is our voltage primary? It's 230. We're being asked to find that initial current. Our voltage secondary is 5. Our current secondary is 1.2. So it's 230x or IP equals 6. Divide both sides by 230. So do 6 divided by 230 to get 0.0260. There's your final answer. Charger X transfers a charge of 10,500 coulombs to the mobile phone battery. State the formula linking charge, current and time. It's Q equals IT. Calculate the time in minutes to transfer a charge of 10,500 coulombs to the battery. You don't need to rearrange this equation if you don't want to. Our charge is 10,500. Our current is the output current, which is 1.2 amps, times T, which is time. To find T, we divide both sides by 1.2. 8,750. Remember the unit here is seconds. We need it in minutes though, so divide that by 60 to get 146 minutes. Charger Y can also be used to charge the mobile phone battery. Diagram 2 shows the information label for charger Y. Explain how the time taken to transfer the same amount of charge to the mobile phone battery will be affected when charger Y is used instead of charger X. So what's true about charger Y? We can see that the output current is greater compared with charger X, which means that the time will be less. So charger Y will take less time to charge the battery because the output current is greater. Both chargers contain step-down transformers. Explain how a step-down transformer works. You may include a diagram to support your answer. I actually will for once. There's our soft iron core. Because it's a step-down transformer, it means that we'll have fewer turns on the secondary coil. More turns on the primary coil. Let's start by stating that a step-down transformer reduces voltage. And then we need to get into the in-depth explanation as to how these things work. So the alternating current produces a magnetic field in the primary coil. We get a mark for just pointing out that it's an alternating current, because remember, direct current won't allow the transformer to work. That alternating current sets up a changing magnetic field in the soft iron core. magnetic fields interact with the secondary coil, which induces a voltage in the secondary coil, and that's how you guarantee your 4 marks. Sound waves with a frequency above the range of human hearing are known as ultrasound. State the frequency range for human hearing. You need to learn this. It's 20 to 20,000 hertz. The frequency of ultrasound waves can be determined using an oscilloscope. Give the name of the piece of apparatus that could be connected to the oscilloscope to detect the ultrasound waves. So what type of apparatus detects sound waves? It's a microphone. The time period of the ultrasound must be measured to determine their frequency. Describe how the oscilloscope is used to measure the time period of the ultrasound waves. So remember, with the oscilloscope, you get this sort of thing where it shows you the waves, and then the time period is the time taken for one complete wave cycle. So in terms of how we actually set up the oscilloscope, you want to adjust the oscilloscope to obtain a steady trace, or you could easily just say freeze the screen. Then you want to adjust the time base to display at least one complete wave cycle on the screen. Count the number of squares that make up one wave cycle. The diagram shows the oscilloscope screen when an ultrasound wave is detected. The oscilloscope settings are shown. Determine the time period of the ultrasound waves. So remember, time for one wave. So let's identify one wave by first of all drawing the equilibrium line here. Oh, they've been so annoying how they've drawn this, because remember, a complete wave looks like this. So we need to try and identify that. So because they've kind of sawn it off a bit, it's actually like here to here. So now let's count the squares. It's 1, 2, 3, 4, 5, 6. So 6 squares along the time base, which is the x direction. So 6 times 5 times 10 to the minus 6, which is 3 times 10 to the minus 5. Calculate the frequency of the ultrasound waves. So frequency equals 1 over time period. So use that number from above. (33,333 hertz). The table gives some statements about different parts of a nuclear reactor. Place ticks in the boxes to show which statements are about the moderator and which ones are about the control rods. So control rods, remember, absorb neutrons to slow down the reaction. The moderator slows them down to increase the chance of fission reactions taking place. So absorbs excess neutrons, control rod. Can be made of boron. The control rods are made out of boron. Can be made of water or graphite. That's definitely the moderator. Is lowered into or raised from the reactor core to adjust the rate of reaction. Again, the control rods. Reduces the speed, so they're more likely to cause fission. Yeah, I already said that. It's the moderator. Describe the role of shielding around a nuclear reactor. Remember, this is often concrete lead, and it's to stop radiation escaping. And the way it does that is by absorbing gamma radiation or extra neutrons. A uranium fuel rod is made from fuel pellets that contain uranium-235 and 238. Only 235 undergoes nuclear fission. energy is released when 235 undergoes fission. The box gives some data about a uranium fuel pellet. The mass, percentage by mass of uranium in the fuel pellet, the mass of uranium-235 atom, total energy released from fuel pellet. Calculate the number of uranium-235 atoms in the fuel pellet. So we need to do 0.0088, which is the mass of uranium in the fuel pellet. We need to work out what 3% of that is. And then take that number and divide it by the mass of one atom of uranium-235. And that gives you 6.8 times 10 to the 20 number of atoms. That's a very large number. That's quite a lot of work for 2 marks. Calculate the energy released when the nucleus of a single atom of uranium-235 undergoes fission. So we take that total energy released from the fuel pellet, which is this number of joules, and then divide it by the number of atoms we've just calculated. That becomes 3.19 times 10 to the minus 11. The universe began with an event known as the Big Bang. Describe how the size and temperature of the universe has changed since the Big Bang. So the universe is expanding. So there's the size answered, and is getting cooler is the temperature part. Discuss 2 pieces of evidence that support the Big Bang theory. 6 marks, wow. So really they're after redshift and CMBR. So let's start with CMBR, cosmic microwave background radiation. My hands are so cold. It's winter here in the UK and I'm struggling to write. Notice that it appears to be the same in all directions. Which implies that all parts of the universe were in contact a long time ago. Hence the Big Bang, which was a huge explosion. Then we'll talk about redshift. Redshift, so what that means is that light from distant galaxies appears redshifted. Remember, this indicates that the universe is expanding. Because that wavelength of light is getting longer, hence redder. The furthest away galaxies are the most redshifted. And therefore are travelling the fastest away from us. I'm so sorry about my handwriting. Pray for my hands. This question is about specific heat capacity. State what is meant by the term. The heat energy change needed to increase the temperature of 1 kilogram of a substance by 1 degree Celsius. Why is there such few lines available? A student uses this method to measure the specific heat capacity of water. Place an aluminium block of known mass in an oven at a temperature of 220 degrees. Place water of a known mass in a container at 20 degrees. Leave the aluminium block in the oven for 10 minutes. Remove the aluminium block and place the block in the water. Measure the maximum temperature of the water after it's been heated by the aluminium block. The student uses their data to calculate the specific heat capacity of water. Give 2 ways that they can improve their method to increase the accuracy of their value of specific heat capacity. Well, you're going to suffer from heat loss to the surroundings, which will give you an inaccurate maximum increase in temperature. So let's add some insulation. So heat loss to the surroundings may be reduced by adding insulation to the container. And then a nice simple one, repeat and calculate an average. You could have also said leave the block in the oven for longer, check that it's definitely 220 degrees, transfer the block from the oven to the water as fast as possible, place a lid on the container. Again, that will help prevent heat loss. Very similar to the specific heat capacity questions in chemistry involving polystyrene cups. The box shows the student's data. When the water reaches its maximum temperature, the water and aluminium block are in thermal equilibrium. State the temperature of the aluminium block as it reaches thermal equilibrium with the water. It's 38 degrees. Calculate the temperature change of the water when it's heated to its maximum temperature. So it's the difference between these two numbers, so it's 18 degrees Celsius. The water gains 190,000 joules of energy in its thermal store. Calculate the specific heat. So E equals mc delta T. So we're after C, the specific heat capacity. Here's our energy. There's our temperature change. So sub in all these numbers, so that's 190,000 equals the mass of the water, which is 2.3 kilograms, times C, which is what we're after, times that temperature difference. Let's sort out the right-hand side by doing 2.3 times 18, 41.4 C, divide 190,000 by 41.4, 4589 to 4 sig fig. After finishing the experiment, the student removes the aluminium block and places the container of water into a freezer. It loses energy at a constant rate and cools from 38 degrees to minus 20. The water freezes and turns to ice at 0. Ice has a lower specific heat capacity than water. Use the axis to sketch a temperature time graph from when the water is placed in a freezer until it reaches its lowest temperature. So we are going to start at 38 degrees. We know that it's going to cool down to 0 degrees, so it doesn't really matter how long that takes. But then it's going to go all the way down to minus 20. Remember, it will take time for it to freeze, so we need a horizontal portion of the graph here. And then this point where it says the ice has the lowest specific heat capacity, that means it takes less energy to increase its temperature. So we'd expect the graph line to actually get a steeper gradient. So something like that. So do make sure that these gradients are different.